Good afternoon, ladies and gentlemen. My name is Paola Capriolo. I'm the Chief Revenue Officer at Drivesec. It's an honor to host you at this webinar today, where we will offer our vision of cybersecurity testing automation in automotive engineering. Let me introduce first our relator, CEO and founder of Drivesec, Giuseppe Faranda Cordella. He has graduated in computer science from the University of Torino. He's an executive with over 30 years of experience in the development of electronic systems for vehicles. During his career, he has held various top roles in leading companies in the automotive sector, whether a manufacturer or tier one. In 2017, he founded Drivesec with the aim of developing cybersecurity solutions dedicated to IoT systems. The company, based in Turin, is establishing itself as a strategic partner to achieve compliance with cybersecurity regulation in the reference sectors, supporting key activities with tools capable of optimizing and speeding up processes necessary in a secure by design product development logic. So before handing the floor over to Giuseppe, just want to add that you can send us during the presentation also your question using the Q&A function on the bar. Of course, we will reserve some time after the presentation to answer. Thank you. Enjoy the webinar. Please, Giuseppe.
Welcome everybody. Thanks, Paola, for the introduction. So you said most of the things that I wanted to say to introduce myself, so we can jump straight to the point of the webinar. Let me share the deck that we have prepared for today's call. The webinar will be recorded, and after we'll send the link of the YouTube channel on which we'll be publishing the webinar, or you can also request the deck and we'll be sending that to you. So as Paola was saying, Drivesec started as a company in 2017. We are all automotive guys, and we all come from an experience in the automotive sector, and we decided to set up the company in the cybersecurity space of embedded systems. So we do engineering of security mechanism and validation and testing of cybersecurity feature and vehicle posture, considering that we approach cyber physical systems like ECUs or any other type of system that you may have in your vehicle or in your environment. Automotive for us is the most important sector. First, because we come from there, and the second reason is that it's the first vertical in the IoT space that is giving himself a mandatory regulation, that is the UN Regulation 155, that probably most of you already knows, that enter into force for a new type approved vehicle from July 2022 and will be enforced on all new vehicle, on a new produced vehicle, so a new immatriculation per se from July 2024. As Paola was saying, we do two things. One is more tactical, that we do support company in achieving the homologation requirements. So we support the homologation process, and in parallel we do, that is the strategic part of the company, we design tools to do testing of cybersecurity requirements and cybersecurity posture. We all know that this is a very hot topic in the automotive, and this is why we choose this sweet spot that is the one of supporting the security by design of IoT and automotive systems. Let me start with the topic of today. So how do we ensure and how we manage a cybersecurity assurance process in the automotive space. This is a question that we face every time that we talk with the OEM and Tier 1. We will start telling what is the way in which OEM and Tier 1 today approach the topic of the assessment of cybersecurity posture that is typically through a pen test. And the question is, how do I learn from the penetration test and from the experience that I do vehicle after vehicle? How do I make sure that the penetration test that I am executing or that I request to a service company is worth the money that I'm spending, and how long a penetration test should last? Okay, so is 5 weeks enough? Is 8 week enough? Well, since penetration, since cybersecurity is not a performance but is a continuous process, there is no real answer to those questions. So we'll enter the discussion and we'll show you what is our approach and our suggested approach to this topic. Just to set the scene briefly, we all know that there are big trends in the automotive. There are connectivity. There is the topic of over-the-air update that again is becoming paramount in the management of a vehicle for OEM and Tier 1, since there is a continuous integration process. There is a continuous process of fixing bugs, delivering new feature that is jeopardizing a bit the traditional waterfall approach suggested by the V model. So the development of a vehicle now is more similar to a DevOps approach with continuous integration and continuous update of software. So also the validation of feature and the validation of cybersecurity posture should follow these approaches, should follow the same speed. The other big topics are autonomous vehicle and software-defined vehicle. That is also making the thing worse, our life more complicated under many point of view, because software need to be verified, updated, validated, and distributed. And among the chain of software development, there is always the risk to fall in some mistake that can expose our products to vulnerability and potential attack. Moreover, there is this topic of the GSR, the General Safety Regulation, that now is including into the homologation requirements, also cybersecurity requirements. And this is imposed to cover cybersecurity and to control cybersecurity posture during the entire life cycle of a vehicle, considering that the system, the requirements impose a request that a system is controlled and monitored also when it is released. This is making life of OEMs and Tier 1 more complicated and require new skills, a new activity and new tools into the management of the integrity of a vehicle. So what is happening today, and what we believe are the major issue. So today, what is happening is typically at the end of the development, when you are close to the final acceptance of the vehicle performance, typically OEMs are requesting a penetration test, either at component level or at a system level, at vehicle level, and they trust on the results of this testing in order to request a certification to the technical service. And this is sometimes seen something like a magic things that happen. You deliver a vehicle, you get a report, and you have to trust to the reports and to the people who has made the test. But it is pretty clear to everyone that this is not the end of the testing or the cybersecurity assessment of a vehicle, because when you release new fix, when you release new over-the-air update features and such, you need to continue to test, and you also need to continue to test after you release a product, also because there are vulnerability that maybe has not been found or can found as a 0-day vulnerability, or new vulnerabilities may appear at every level of your product. It can happen on the hardware level, software level. So this is something that need to be continuous, and continuous testing is required. And to support a continuous testing, you need to go towards automation of this testing, because otherwise you'll be spending a lot of time putting at risk your launch date. You'll be spending a lot of money, and more important, you don't have control of the cybersecurity testing and what is really happening on the system that you are putting on the market. So there is a need of something new, or something changing in the space of cybersecurity assessment, that should go in the direction of including automation, including continuous monitoring, including the build of a knowledge base that an OEM and Tier 1 should build internally in order to be sure that they can grow in knowledge and capabilities, and they control the process of cybersecurity testing, and don't leave in the hand of someone else the problem of finding vulnerabilities and ensuring that the cybersecurity posture of a vehicle or a components is at the right level, or where we expect it to be. So those are a lot of things that are to be considered when building a cybersecurity assessment model. More important is also that we believe that testing a steady vehicle in a garage, like when you deliver a vehicle to a service company for a penetration test, is just bringing you a level of assurance that is not at the level that you want it to be, because you are not testing all the feature. You're just testing the vehicle feature that can be tested while the vehicle is not running. You cannot test or you cannot be sure that you find a vulnerability during an emergency braking maneuver or an overtaking maneuver, because you cannot test or you cannot try to attack a vehicle that is moving. So you need to be able to test your capability and your feature on a control environment that typically is a development bench connected to hardware in the loop system, so that when you test your cybersecurity requirements, you are also you can also trigger new scenarios, trigger new feature to the hardware in the loop systems, and make sure that you enlarge the base of the perimeter of your testing. So those are all things that need to be taken into account while building a strategy for testing a vehicle or testing an automotive systems. So our vision is to bring a tool and a system on the market that is transparent, is automated and autonomous, help the build of a knowledge base, and help to build on the lesson learned, and enter in approach that is proactive and is leading to a continuous improvement process. That is what typically OEM and Tier 1 are pursuing on all the other type of requirements. So why this should be different in an environment that includes cybersecurity requirements? So the point is that our product, our vehicle will be attacked, and the risks are becoming more and more important. So the point is that we need to be in a position that we outperform attackers in search of threats and vulnerabilities, so that this threat and vulnerability can be fixed as soon as possible, as soon as they come out, and as soon as we discover them. Let's see, from what we say, that we have sketched a few charts to explain our idea and our approach. So today, what happened in the approach is that you start from the item definition, from the definition of the different feature that you are running into a car. Today, typically the approach is to go to a TARA, a threat assessment, threat analysis and risk assessment tool that is indicated by the UN regulation 155 as a tool to identify risk, identify mitigation for the risk, and make sure that all the risks are, managed in an environment. These requirements are defined and distributed to the tier 1, tier 2, etc. Software is developed also on a cybersecurity level, and then there is the traditional process of cybersecurity requirement validation. And after that, as we said, as soon as you are happy with the testing, we are full develop, you go today typically for a penetration test. You wait for the result. If there is something that need to be fixed, then you have to go back to the design table, and after these things are fixed, typically OEM tier 1 goes through a retest of the fix, and you go to the market. And this is something that today is the typical approach. What is requested by the UN regulation 155 is that after you go to the market, you also enter a monitoring phase where you try with the support of the tier 1 to control the vehicle that are running in all around the world to make sure that nobody is attentioning your systems. You typically do to a TI, a threat intelligence type of approach, where you go and search in a deep web, dark web for vulnerabilities or for people that is exchanging information about your system, or you put in place a VSOC, a Vehicle Secure Operations Center, from which you collect data information. So after you get some feed from your TI or VSOC, and you identify something that need to be fixed, you go to the fix of this vulnerability. You deploy you do the testing. You decide whether you want to redo a penetration test or not. Once you are happy with your penetration test results and the fix that you have applied, you go to the market and you re-enter into the monitoring phase. After, you can decide which vehicle model or which system requires an update of the software in the field. Same things happen when you need to deliver a new feature, and so you have some update. So typically you have update requirements. Those requirements need to be implemented in the code. The code will be checked. You re-enter require validation and testing. If those changes are relevant enough, you go again from a penetration test. It can be at component level, at system level, and you deploy this new feature to over the air, and you go to the market and you restart monitoring. So it's since this is a continuous process till the end till the dismissal of a vehicle model, etc., you understand that you have to continue. So the penetration test that you execute at the end of your development, when you go for a type approval, is just a first step. Something that so the testing of requirements need to go on a continuous process and a continuous level. So the point at this of this discussion is that you need something to support the automation. So especially today in the part of cybersecurity requirements and validation, let's say talking about extended vulnerability assessment, you need, or you may need, something that execute these things automatically, so that when you go to a penetration test, you have done at least a pre-check or a self-assessment of the security posture of your product. So thinking to build a new model for cybersecurity testing, we started to think to an approach that is based on a what we call a cyber knowledge base. Cyber knowledge base is a set of script, is a set of tools that you develop or you buy from third parties that help you to test automatically the cybersecurity requirements, try to execute fuzzing of your systems, and simulate attack of your components and your vehicle during the validation phase before you go to a penetration test. So every time that you build a new piece of software, every time that you enter validation, you can support this validation through the use of a script that has been developed or been stored into a knowledge base, and can be used to emulate the potential test that will be executed by a penetration tester, and things that can be used by an attacker to sniff your data, to try to find vulnerabilities. Of course, this is today the state of development of the system today. You cannot fully avoid the penetration test. So at a certain point, you have to run a penetration test as usual. But the point is that you arrive to the penetration test with a level of testing that is ensuring that at least the most common vulnerabilities, so everything that you have learned from the past has been tested. And this knowledge base should grow penetration test after penetration test. So you should be running a penetration test with the company you like. The results of this penetration test should be delivered also under the form of script, not just under the form of a report. Those scripts should be added to your knowledge base. So the next type that you deliver a new software version for a specific component, you are sure that some of these tests are also executed in the extended validation or external vulnerability assessment of your components. Same thing should happen when you go for monitoring. So when you have a service contract, like a threat intelligence contract or a VSOC or a VSOC service, and you get a feed, those feeds should be converted into script that test the problem that has been outlined, or the indication that comes from the vehicle stock. So that in a first step, you can check whether the information or the attack path that has been identified in your threat intelligence report can be really deployed on your system. So you transform the results of the information of the threat intelligence into a script. You test automatically the script on your vehicle. You verify whether this type of attack can be deployed on your final system, and you store this information into your knowledge base. So the next vehicle that you deliver, the next system that you bring on the market, will be also tested on the information that you have find on the dark web during the monitoring of a specific vehicle model and such. So this lead to the construction of a database, of a knowledge base that support a continuous improvement process and help OEM and Tier 1 to grow in the ability to control the process of testing and automating the cybersecurity assessment of the vehicle. Having a tool that allows you to execute these things automatically, starting from a knowledge base, will help you to reduce cost, to test also continuously, even when you finish your development and you enter in a monitoring phase. You can continue to test on your benches, on your hardware in the loop systems, and also more important, you can have the same kind of testing attached to simulation environment, like digital twins environment and such, because at a certain point, especially for the tier one, you will be dismounting your benches, you will remove your hill system from the validation and testing chain, and you will use a simulation environment to do the testing and continue monitoring of your system, and being able to connect an automated test and to do maybe also penetration test on a simulation environment is something that will help you to control the cost, control the quality, and continue to deliver something that is secure to your final customer. What do we mean, and how do we think that a knowledge base should be built? I say that the knowledge base is something that is a collection of script that can come from the OEM requirements. So the tool that will support you in your continuous improvement and continuous testing of cybersecurity requirements should start from should be connected to the tool that you will be selecting to manage your requirements, because cybersecurity requirements are just like any other requirements. So you define the way in which you will be testing your secure boot on one of your ECU. You will be preparing those tests. Those tests will become scripted. The script will enter the knowledge base. Other scripts will be generated starting from the information that are coming from the TARA, from the regulation requirements. For example, you know that into the Annex 5 of the UN Regulation 155, you have a list of mitigation that need to be checked or are suggested by the regulation. You should be continuously monitoring CVEs, CWEs, and other database of vulnerabilities and weakness, and transform this the weakness that are related to your specific product connected with what you have in your hardware BOM or software BOM and such. Translate this into script, put the script into the database, and use this database to test automatically your system as soon that you continue to bring system on the market. Of course, it's something that is a big effort initially, but it's something that become pretty natural in the future, and is already part of what is done to validate a vehicle today. This knowledge base should also include attack simulation scripts, fuzzing scripts, and such. And into your specific knowledge base, you will have also feed scripts that are coming from the conversion of threat intelligence feeds or VSOC alert into script in order to continue to improve your ability to test and assess security of your system as long as you continue to deliver product on the market. So this is this type of approach and the type of system that we are thinking that can benefit the community and can benefit the entire automotive world. We have designed a platform that support this type of approach. This platform, you can find information on our website, is called WeSet, and WeSet, that start from We Secure Things, that is our motto, is a platform that actually support OEM and tier one to do automated testing based on a knowledge base, that start from a test of script that are already designed and that we will continue improve in terms of number of tests. Today, our tests cover everything that is specified into the Annex 5 of the UN regulation 155, but OEM and Tier 1 can add their own test to the knowledge base and build their own knowledge base, starting from what we are delivering along with the platform. The platform is based, you will see in the next chart, is based on a box that we distribute to our customer, and this box can be integrated into vehicle, into prototypes, but more important, can be attached to test benches, hardware in the loop systems, and such, so that you can decide in which scenario you want to execute the script and you want to run the test. If you and this will help you expand the perimeter of the test that you will be running before you go to a penetration test. So we set support automation and the build of this knowledge base for OEM and Tier 1, and moreover also support the execution of penetration tests from remote, which is a quite pretty unique feature, because most of the time you know that you need to deliver components, vehicle to the company that will be elected as your cybersecurity assessment partner, and this requires time, require parts. And requires some time in order to start the test. Being able to execute a penetration test from remote will support you in being more efficient also on this part of your test. Let me show you how the WISE platform is defined. WISE platform is composed of a number of elements. The basic element is the WISE box. The WISE box is the components that we deliver to our customer to be integrated into prototypes, into integration benches, hardware in the loop environment, and such. And the WISE box is equipped with a number of interfaces that cover, the entire span of vehicle interface today: CAN, CAN-FD, Ethernet, FlexRay, Bluetooth, Wi-Fi. We can manage digital I/O. We can stream video from remote. We can grab a frame from the VDS, control digital I/Os, control, emulate the plug or unplug of a USB device from remote, and such. So we provide remote researcher with an open tool that they can customize, that allows them to execute the safe time.test script in fuzzing and such, that can be executed when in proximity of a components. This will have a number of benefits, of course. The most important is that you solve a big problem in logistics. You will need less parts. You can invite a cybersecurity researcher very early in your validation process, not just at the end when you have closed the environment. And an advantage that is not negligible is that if you have to test an electric vehicle, maybe you don't want people to be in proximity of a high voltage equipment, right? So testing from remote has a number of other advantages. The other advantage is that if you want to follow the approach of bug bounty, you can do that through our platform. That secure the pipe from the system under test to the tester in a pretty unique way. And we'll be happy to provide you more information about this topic. Under the point of view of the OEM or the Tier 1, the platform, our platform is attached to a test script database that, as we said, is already equipped with a large number of scripts that some of these are generic, some of these will require some customization, but can be the test engineer can control the execution of those scripts, can select the script, command the box to load the script into the box, execute the test on the bench, and report back the results. So that when you have your database, you add more script, you can control what is inside the database, that the knowledge base that you're managing, and you can decide to execute the test whenever you want. And our platform is also capable to interact with your DSpace environment or National Instrument environments when you are integrated with the hardware in the loop system. This is almost what we want to present you. So the topic of today is you need to have a way to control and to grow in capability to test and make sure that what you're bringing on the market is safe. And since you need to continue to test, you need to control the process, and you need to have a tool that make you save time and money in your testing approach, and something that also help you to do a better integration with the people who need to find vulnerabilities and people who need to fix vulnerability, because our platform will support a cooperative vulnerability fixing approach. So every time that you discover a fix, you can involve your software guys to fix it and enter in a continuous delivery process, helping you to continue to develop a system that is safe and tested. There is the Wisa platform is an environment that allows you to integrate automated control and human-based control with the integration of remote penetration tests that are needed. Of course, we all say that the penetration test is a key part of your testing strategy, but is not the only part that you need to implement. And when you involve a human being in a test of a vehicle, you need to involve him in a way that he can stress your system under all the conditions, not just on the condition of a steady vehicle in a garage. So there, just to conclude, this is the last slide that I wanna show you today, and then we enter on the Q&A session if there is any question. We are, of course, open to answer your question. We invite you to reach us if you're interested into the approach, because this is something that need to be discussed together, built together. The integration of our platform is zero setup time, so the box does not require any customization. But of course, we need to work together to integrate our platform into your testing approach to make it more reliable, more transparent, and continuous, and also less expensive. Thank you.
Thank you for the intervention. To give some space for your question, he has made a real ultra fast presentation. So if anything is not being so clear, this is the time to ask. Please.
Yeah, I apologize. You don't need to listen the recording at double of the speed. Probably you can
you can ask him.
You can reduce the speed of your video. Okay. Is there
Anyone?
any question? Any? Good. Super clear.
One question. Are you considering the FATS testing as part of pen testing? Can you perform FATS testing on FlexRay signals?
Okay, let's start from this question that is interesting. So we believe that in the process you have to go to different steps. The first is the vulnerability assessment. Then you do FATS testing that can be done either on network or on the software, on the different interfaces as part of the library that we deliver on on the system, we do FATS testing. You can use our tool, or you can integrate other fast tool that can be executed on our box. Consider that the box is Linux based environment, so we have different executions environment that can be used. But yes, fatsing is a big part of the story. About fatsing FlexRay, yes, we work on FlexRay. The box we said is equipped with a number of interfaces that can be connected. In the case of FlexRay, we connect the box to a components that is the vector VN 7620, if I'm not mistaken. We can be more specific. So we interface our box to the FlexRay interface provided by Vector, which I believe is the one that you're using is the most common one today. If you're using on your bench, we have emulation of the protocol to, let's say, interact with the FlexRay from our box and from remote. So hope this answered the first question. How did you validate your tool? I see as another question. So the first part of the answer is more connected with the fact that we want to deliver a tool that is it cannot be attacked by intruders. I mean, when deliver a box and our customer deliver a box that can be accessed from remote, they need to be sure that we are not shipping Trojan horses in their environment. So we do penetration test, regular penetration test assessment on our platform to control that the entire platform is safe and cannot be intruded, but can only be accessed by the people in our organization. If the question is related on how we validate our script, we have our own internal benches. So before we deliver a script, we test on benches here locally. We have a different number of components with different interfaces. But of course, since a script can be produced by the tier one or by the OEM, the validation of the script that will be installed on a knowledge base need to be done by the organization who is delivering the script. We do, as a company, penetration test for components and systems. So we use our script, and the script that we are using is a script that we are normally use also on our regular activities. I don't know if this is answering also the question.
One more question related to pen test on the chat. How can evaluate that a pen test has reached this scope?
Sorry. No, I was just reading the normal, the other part of the fast testing.
Okay.
So this is a big point, but this is a point that is not only valid for fast testing on the specific FlexRay. So the platform, the remote platform, as I was mentioning, can be equipped with a camera and a mic, so you can check from remote whether the type of attack that you have done on an infotainment system or an instrument cluster connected to a FlexRay network has been successful, because you can monitor with the camera, or you can connect our tool to a frame grabber on the specific LVDS interface, for example, so that we can you can also automate this type of control. This, of course, is something that need to be done specifically on a bench. Is something that can be customized and redesigned. And well, about cache, of course, you can control your network, see if a node is not responding anymore, and such. So there is a number of control that are connected with the fuzzing, with the fuzz testing that check if a system is used responding, sorry, or if something happened on the interface and such. But this can be if there is something specific on fast testing on FlexRay. We can take this offline because I would like you to talk with our pen test guys, because I'm not actually the guy executing this kind of test. I see another question that is how your box is connected by remote to the cloud. The box is equipped with a 4G connectivity device. So the box connects to a dedicated Drivesec APN to our AWS server, which is in the middle between the bench and the remote tester, the person who will be running the test, or we execute the validation. And the reason why we decided to equip with the mobile connection is twofold. The first is because we want to control the entire end-to-end security without involving IT people on the customer side. So you build a pipe. It's a sort of a hardware VPN that you build when you attach our system to your platform. So I mentioned that we are using AWS as a service for our cloud. We connect our box using a machine-to-machine SIM from Vodafone, and we can control a number of things, and we can control the security of our APN, dedicated APN. And the other reason why we implement this mobile link is because especially when you invite someone from a bug bounty program, or you invite a remote attacker, you don't want these guys to connect to your VPN, because these guys are curious. They may look around. So you want to say that they can just connect to a specific resources. So you can connect your box just to a CAN-FD or to an Ethernet, maybe just to one single interface, and ask these guys to test only the specific device on that specific network for a specific time and such. So you really define what kind of resources these guys will be able to see through the use and the control of our platform. So this is the reason why we equip the system. Sometimes we end up in situation where our customer have their labs in caves, let's say, or in environment that are shielded, so we can provide a connectivity through Ethernet that will be connected to the IT infrastructure of the customer. So this is an option. This is not our preferred option, and this requires some interaction with your IT guys, because we have to set some extra security feature and request the opening of some specific service on your firewall, which is not always something that your IT guys will be happy to do. But yes, we can also do that. It's not our preferred it's not the preferred environment, because it requires some extra work, but yeah, it's we can do that.
Any more questions?
Yeah, we are almost done with the time that we set for the meeting today. We thank you all for being with us. You can find we'll distribute the link where you can find the registration. You can also ask for the deck. We're more than happy to distribute the deck to all of you. If you need extra information, you can reach me or Paola to the different link that we'll be adding to the communication at the end of this webinar. If you are interested to approach, we have a proof of concept program that will be more than happy to run with you, which means that we can deliver you a box and run a proof of concept that will last some months, 3 or 6 months. It depends on your request and your needs, and we are more than glad to support you in the part of securing the automotive environment. Thank you.
Thank you for your participation. Have a nice evening.